I thought I'd let Dilbert do my opening joke. He does a lot better than I do. I don't have 397 slides, and don't want to poison anybody. So we had a job on FM 99. FM 99 is in northern Live Oak County, and I want to just kind of provide some background on that project before we get into the foam stabilization. This is a slide of all the Eagle Ford activity through August. Don't know if you can see that in the back, but we've got permitted wells, on schedule oil wells, and on schedule gas wells. I just added those up, and through August we have almost 16,000 wells throughout that play. We drill down a little further and look at it from a time-lapse view. You can kind of see here the changing dates and the changing conditions, or the amount of wells increasing through time. Kind of blows up in 2010, and well, we know what happened after that. Looking at it a little bit closer, this is the location of FM 99 within the Eagle Ford play. FM 99 sits up here, right in the northern portion of Live Oak County, kind of right in the middle of the play. So we've got a lot of oil field traffic going back and forth, and it has some pretty detrimental effects. This shows something I pulled from online, kind of showing FM 99, our project limits, which is in red. These are some of the county roads that are nearby, and of course all the different oil wells. So just in that picture alone, just in that snapshot, there's something like 50 to 60 active wells. But FM 99 does continue to the north, does continue to the south. These wells here can only be accessed through 99, and it's adjoining county road, so there's a tremendous amount of traffic. Kind of give you a different perspective, an aerial view. You can see all the different pad sites. Looked at the crashes. In the last 5 years or so, we've had 13 crashes, differing degrees, but a high number nonetheless. This is where we were. You can tell from the condition of the road that it's pretty bad. We've got edge condition issues. We've got failures, lots of cracking, and for those of you who have worked in an area office, the public tends to call a lot, very angry on the condition of the road, and this could be me, this could be maintenance supervisor pulling their hair out, because it's just so difficult to address that and have some sustainability. So we know we needed to do something, and we needed to do something quickly. So the way we approached this project was to widen the edges for width. We had maybe a 20-foot road at best. So we knew we needed to get some width out there to correct our edge drop-offs, but we also wanted to add a little bit of structure to help with the, to help, of course, with the traffic loading. But it's a balancing act. We only have so much money. We need to address our safety needs first, primarily, and with a little bit extra money, we can add some structure. But I'm sure a lot of you in the room dealing in the energy sector know that it is kind of walking a tightrope. We're just trying to buy some time to get us through next few years. We don't really know if this pavement design, quote unquote, is going to give us 2 years, going to give us 5 years, 10 years, but we know we had to do something. So that's where we started. Like I said, we widened the edges. cement treated all the way across for a sub-base and added 6 inches of new base on top with a two-core surface treatment. So that was our initial approach. Back in May, we had an energy, or in March, I believe, we had an energy sector workshop in the Corpus District. And it was there where we initially heard of foamed asphalt. There was a project planned for State Highway 85, if I'm not mistaken. And that kind of piqued our interest. We said, we kind of started talking amongst ourselves, what is foamed asphalt? We wanted to make it out there to San Antonio to take a look, see what was going on. Subsequently, that job didn't make. And so we took that as an opportunity to dive in a little bit further, and maybe we could use that technology on FM99 job. The FM99 job was already ongoing, so we started asking questions, started asking more questions. Got with Tom, TTI, and the folks in Maintenance Division to start looking a little bit closer at it, gather some samples, do some testing to see if that was a candidate. Quickly, of course, because we had the job ongoing. So you can see here, this job is already under construction. Contractor has already widened on the edges, and together with our maintenance section, we went out and we started sampling some material. So this was, like I said, this was an ongoing project. So we took some samples, shipped them up to Tom, and made some samples. So you can see here, this is the testing equipment. This pug mill has a nozzle that is exactly the same as the nozzle you would see on the mixer. So it's a good representation of actual field conditions. So we were working here between 2.4% and 2.7% asphalt and 1.5% cement. Made some samples, three wet, 3 dry, and subjected them to the indirect tension test. And here is kind of a snapshot of some of those results. So you can see here with the 2.7 and the 1.5, we had a tensile strength ratio of 50, and with 2.4 and 1.5, 2.4 asphalt and 1.5 cement, we had a tensile strength ratio of 55, and that is between the wet and the dry strengths. So we went with the mixed design of 2.4 asphalt. This was our resulting typical section. Of course, we already had the widening off the edge of pavement, and we went ahead and added the 6 inches of new base on top as originally designed, and foam treated 11 inches. It was a roll of the dice. We really didn't know what to expect. We hadn't worked like this before. It did cost us some money, and Tom, I didn't intend to portray you and your team as witches, but in the spirit of Halloween, we just threw it together. It's old base, new base, existing surface, asphalt, cement. There was a bit of skepticism in the beginning, if this would all work, but we moved forward. We initiated a change order with the contractor, and we started work. So just some quick background on the foaming process. There should be another. There we go. So this is what happens in the chamber. We're injecting the hot asphalt, some water, some air, and what comes out the other side is an asphalt cappuccino. You can kind of see the mixing drum here, and everything gets injected. There's plenty of room up here to mix 11 inches. What is of note in this process is the actual compaction water is included as well. So on the back end of this mixer, you're ready to compact. Some of the mechanical processes that's going on in there is the foam. Of course, we need more volume to get good dispersion in the entire mix. The foam and the fines adhere to each other, kind of make a mortar, if you will. But the foam does dissipate relatively quickly. So it does need to be mixed immediately, which is why everything's injected into the drum. You can see here that right out of the machine, it foams up relatively quickly, gets up to the top of the bucket, and then dissipates. And we measure that in terms of a half-life. And the half-life, of course, is real important because you don't want the asphalt to dissipate too quickly before it has a chance to get adequately dispersed in the mixing chamber and adhere to all of the fine material. So moving on to the construction process, we use special spec 3279. You kind of read up there. Basically, it is mix everything together and add asphalt foam. This is what I was referring to as far as the foamed asphalt properties. Of course, you want it to expand. Minimum is 8 times its original volume, and you want it to last for at least 6 seconds, again, just to make sure that it does get adequately dispersed. Some information on the reclaimer. I won't read those for you, but some things to point out is it's a 600 horsepower machine. And I'll move forward into some of these other slides that show the process, but it's got to have plenty of power to push and pull the asphalt tanker and the water truck. Talks about the spray bars, self-cleaning, which is important. You want to make sure you get a uniform application of the asphalt. Inspection nozzle at the end of the spray bar gives you that sample I showed just a minute ago in the bucket, so you can get a representative sample daily to make sure we have the right properties for the foam. This is the machine that was on the job. It's pretty impressive. One of the neatest tractors, if you will, that I've seen. It's got a lot of automation included with it. Probably can't see from way back there, but it'll tell you real time how much water you're adding, how much asphalt you're adding, how far you've gone, area treated, plenty of information. You can see here that the water and the asphalt are connected directly to the machine, and all the magic happens in there. This is a quick animation.
For cold recycling with pre-spread cement and foamed bitumen, a Streumaster binding agent spreader pre-spreads small amounts of cement. Computer-controlled metering feeders ensure high spreading accuracy. Behind the spreader, a water and a bitumen tanker truck. The Wirtgen recycler draws in the binding agents via hose connections. The recycler is equipped with push bars to push the 2 tanker trucks along. The powerful milling and mixing rotor granulates the damaged pavement layers. The pre-spread cement is mixed in at the same time. A special injection bar with expansion chambers produces the foamed bitumen and sprays it in. Water added to the process causes the bitumen to foam abruptly, expanding it to many times its original volume and distributing it evenly in the mineral aggregate mix. At the same time, the amount of water required for the mixing process is added via a second injection bar. Compaction is effected by Ham single drum compactors, one with a pad foot drum followed by a second one with a smooth drum. Next comes a grader for finish grading. A tandem roller and a pneumatic tired roller complete the compaction process to produce a uniform, sealed surface structure.
That animation was provided by the equipment supplier, Bertkin. Mike, thank you. This is what it looks like on the ground. Another quick video. You can see the water truck. In this case, the water truck was being pulled. We've got the machine in the middle with the asphalt tanker being pushed. Recognize that guy? So immediately after mixing, like I mentioned, it's ready for immediate compaction. See here we have the 20-ton roller. This is just a picture of what the mixture looks like. I expected that when I grabbed that the asphalt would, of course, bind to my hand, but it didn't. It was pretty well bound to the material. There wasn't any free asphalt, if you will, that was on my hand. So pretty quickly after the 20-ton rollers are on there, we can blade that smooth. I will mention that it took only approximately 5 passes for us to achieve our target density. Finish blade, roll again with the steel drum, and get a good tight finish with the pneumatic, and we're ready for a prime coat. You can see a prime coat application, little heavy. We had to add a little bit more sand to dry up some of that before traffic was put on it, but it was ready for traffic that same day. So again, a before picture and an after. So once that section was completed, we went out with the FWD and took some data. You can kind of see where it falls in comparison to raw base or cement treated base. I will note or point out here that this is one data point for this particular road, this particular mix design. This value will be highly dependent on the mix design and the material. So it's kind of difficult to take this number and just run with it. Just keep that in mind as you move on. So, is it cost effective? So now we need to start looking at the cost. So what are we paying for? Of course, we're paying for the asphalt separately, paying for the cement separately, and then we're going to be paying for the manipulation of the material. For this particular project, you can see that our unit cost for our cement treated base section was $354 a square yard. That's manipulation and cement, pretty straightforward. You can see here the driving cost is going to be the asphalt. So a couple of disclaimers here is it was a small change order, less than a mile, so very small quantities of asphalt. The ownership costs of that fancy machine are not included. The machine was provided as a demonstration. So there are some variables associated with that cost that could take it up or down. I'd say if you did a longer job, of course, economy of scale, that price is going to come down. Get a better price on asphalt with the more asphalt you do use. So just, also keep that in mind. I know we can look at that cost, and it seems very, very exorbitant, but there are other things to consider. So I looked at them. I looked at the two sections kind of head to head because that's what we had on the job. We had one section that was cement treated and the other section with foamed asphalt, and looked at advantages and disadvantages. With cement, of course, we all know cement. We've been working with cement for a very long time. We know it does improve compressive strength, and the cost is relatively low. So those kind of go to help cement on its advantages. But when we're talking about foamed asphalt advantages, is the foamed asphalt section remains flexible. And when we're talking about flexible pavements, of course, we want them as flexible as we can. The more rigid they become, as Darlene mentioned earlier, is more susceptible to cracking. And then, of course, from my perspective, the ease of application tilted the scale, in this case, on the advantage to foamed asphalt. Looking at some of the disadvantages, of course, first on this side is cost, but I tilted the scales again in favor of foamed asphalt just because of some of the issues we know we have with cement-treated bases is shrinkage cracking and increased rigidity. So where are we? Kind of hard to say. We have one project on the ground. I know they've been using this technology in other places around the world and around the U.S., but in Texas we have one data point. It looks favorable. It looks like we have a viable solution. It does appear to be very moisture resistant. As the case would have it, we went home for the weekend, had 4 inches of rain, came back, and I thought I was going to lose my road. Went out there and took a look. Surprisingly, it held up extremely well. And with that type of traffic, after with it being unsealed, unsurfaced, it was pretty nerve-wracking, but it held up very well. The foamed asphalt mix design requires just that, a design, a full evaluation of the in-situ materials, new materials if necessary, any blending, and we're going to need some more testing. We'll watch this section from here on out in the next few years, look at long-term performance, and as we, as a state, move on to more of these types of projects, we can gather a true benefit to cost ratio and find out what is it that we're gaining and what is it that we're spending, and is it worth it? It definitely seems worth it now, but time will tell. I just like Gilbert. So any questions?